And we're back. Yeah, sorry about that. Looks like the stream got cut for some reason. Whatevs. Anyway, so what I was saying earlier was, I was looking at the list of articles basically inside any law. You can pick any of these laws, and you can see that the atomic unit is essentially the article itself, and you have groups of articles formed under, I believe, chapters. So you have 10 chapters in the commercial companies law, for instance. And I wanted to try and figure out like what is the token length of an ad. There's a tool, yeah, the tokenizer tool. This tool allows you to calculate. Oh, it's too long. Okay, interesting. So what about the, let's say, first five chapters? Also too long. Chapter one then? Okay. Also too long? You gotta be kidding me. It's not that long. Hmm. Okay. Um, huh. I guess we could estimate it. We could take the first 50 lines. You can see that 600 tokens. They're a total of 2, 450 over 50, so 49 times how many tokens? 672. 30,000 tokens. You can actually provide the entirety of the law. Um, interesting. Interesting. You could just provide the whole law. Hmm. Hmm. Okay. Right. So anyway, this steps sort of involved here are uh, I guess the first thing we need to do is we need to do some basic research to understand what state of the art looks like, what changes I'm unaware of that we might be able to implement, and then sort of figure out like how we can implement those. Um, the obvious reference would be LangChain. They have a RAG guide here, which we're going to be looking at. Retrieval step to a prompt in LLM, which adds retrieval augmented generation. Okay, so this kind of tells you how to implement it, which I'm sure would be very useful. Um, there's this too. I'm not really sure what that's about. I guess we'll get to that in a second. I searched for state of the art RAG, and then this showed up. Not really sure what all this stuff means, but I just fed it into ChatGPT and asked it like what it thought, and it kind of came back with this. Um, so how to implement this? Data acquisition. Okay, we already have the data. And text segmentation. That's an important thing. We've already talked about that. Like real quick, flag embedding technique. Transform legal text into compact vectors. We'll do that by article most likely. Fine tuned on legal data. BGE by general embedding. I mean, I was thinking of using the embeddings provided by OpenAI. I don't think you need to use any sort of special embeddings. Hmm. Pre-train the model on the segmented legal text. Adjust parameters such as learning rate, batch size, sequence length. Huh. I don't have any training a model, yo. I'm just trying to implement RAG. Okay. Yeah, we don't need legal precedents, at least for contract generation. Maybe in the future you could include that, but I don't think it's necessary for this basic example. Fine tuning. Okay, I think this is entirely useless. Let's see. Okay, this is almost exactly what I'm interested in. Fine tuning state of the art RAG engine, chunk and overlap side. So, what all could you fine tune? I mean, when you have like simple grammar mistakes in your sentences, it kind of reduces my trust in the quality of the output. Well, at least it's human, right? It's human generated, right? Data source normalization. Normalized data vectorization. Is that like normalized in terms of the actual size? Evaluate various chunk sizes with overlap parameters. Okay. 750 to 1,000 words. It kind of seems like in line with, wait, 750 to 1,000 words? I mean, this is how many words? Uh, count, word count? Because you probably need some sort of extension to do word count. Hmm. And you can do it by, what's the longest article? How would you find? This one's pretty long. Oh, and then you have to start the limiter here. Yeah, you have parts, and then you have uh, so you have parts, you have chapters. Hmm. Chapter, part, and then article. Interesting. What else you got? Do you have page in there somewhere? No. I don't know if this applies to all of them or just this. Oh, and then you have the text, the preamble that comes before the actual articles. Okay. Oh, okay. Chapter part article. So VectorDB RAG techniques based on use case, hybrid fusion, query transformation. Okay, that sounds interesting. Re-ranking, Lizer, work here. Prompting, chain of thought plus few shot. Okay, choosing right vector database. What's that? The YC bot? Interesting. GPT generates a hypothetical response to a query. The chatbot then searches vector embeddings closely aligned with this hypothetical response. Oh, so you don't do semantic search on the query itself, but on the response. Why is it so complicated? I mean, the table was useful, just sort of a collection for its collection of technology names. So things like hide and hybrid fusion, or at least the techniques. Um, okay, Pinecone. Okay, yeah, okay. Turn in into an embedding and then do the cosine similarity search. Yeah, that's exactly what I said earlier. Relevant context, so question post context. So the tricky bit is you need to find the right context to provide the generative AI. Uh, so GPT-4 needs the right context. So that's one part of the problem is figuring out how you're going to retrieve the right context given the query itself. And sometimes you just do a straight search based on the query. Sometimes you modify the query to get better results. Um, and the other part to it is also like how do you the work that you do up front, which is actually vectorizing all of the legal references, all of the laws. How do you do that in a way where you ensure that the references that you get back are relevant and complete? Maybe what you need is like the ability to request additional references. Maybe I'm not sure. Hmm. I mean, you want a reliable answer. Uh, yeah, it's not saying anything new here though. Graph schema. Extracting concepts. Okay, you do the graph schema, and then what do you do with that? Like, you use this for generative AI. Graph retrieval augmented generation and chat with our text in a much more profound way using graph as a retrieval. We use a vectory DB. Hmm. Okay, sounds interesting. Do you have any? Is there any demo of this? Doctors? Well, how do you ask questions? What is this? Okay, whatever. Nope. Okay, so we have the RAG implementation here. Um, yeah, that's essentially it. Like you answer based on, I mean, is there no improvement? Has there been no improvement over the last 9 months in terms of implementing RAG? There must be something, right? Chroma and Llama 2. Let's see. All right, we're 15 minutes in. I want to wrap this up in the next 5 minutes. So kind of decide like how we're going to be moving forward and what we need to implement. It's just using LangChain. There's nothing unique about this. All chunks contain start and end pause offsets and a document ID. No text is stored with the chunks. Keep the chunks as small as possible. Mm. Hmm. I'll be paying close attention to this. Okay, it seems interesting, but Vectra, what is this? Local vector database. Interesting. Maybe you can use a technique like this. Um, max sections, overlapping chunks equal true. Um, so it takes like it takes the max tokens that you want to retrieve, and it considers the size of each individual chunk, or it assumes that each chunk would have like some token count reference that you could use. Hmm. Okay. So it tries to get as many tokens as possible, combine adjacent chunks of text. Oh, sort sections by score and limit to max sections. Right. Hmm. Right. How does this work across sections? Interesting. We'll keep that tab open. All right. Okay. All right. Interesting. Wild guess. Hence retrieval without relevance. It's a template, not a feature. Hypothetical document. Encodes the document into an embedding vector. Okay, so it makes up a fake answer and then it tries to find documents based on the answer itself. So instead of embedding the query, you're embedding the fake answer. You're finding documents similar to the fake answer. Right. Okay. Cool. Yeah, I mean, it's possible. Yeah, why not? We'll add that to the list. Hide. And we can take a look at how they actually implement it. Yeah, cool. I think that's enough for research. We'll take a quick break and then we'll continue with the second part, which is